going back to make sure everybody gets what I'm saying. So look at what I'm saying. The topic for the day is confidence interval. The value we are looking for is the parameter, population parameter, and we are going to be using the sample value to estimate the population parameter. So what is a parameter? From unit 1, we know that parameters are population characteristics. Population characteristics are parameters. All right, so, and sample characteristics are called statistic. So we shall be using statistic to estimate parameter. So the first thing we want to do is estimate the population proportion in unit 4. This unit 4, we are starting with population proportion, right? So let's start with population proportion. Let's go read some of the things here we need to know. So already said that the objectives for the day, the objectives for today are, number 1, obtain a point estimate. A point estimate is for population proportion, the point estimate is p hat. So the point estimate for population proportion is p hat. The population proportion is p. What's the difference between p hat and p? You must know the difference. What is the difference between p and p hat? I want you to know that this is the same p we saw in binomial distribution, probability of success. So just make it sure make it easy for yourself. The population proportion is p. There is no hat. No hat. Population proportion. The sample proportion is p hat. We shall be using p hat to estimate the population proportion because we don't know the population proportion. We are not even expected to know the population proportion. Because see, if you know the parameter, what are you looking for? So you usually don't know the parameter. For example, if you're told to find the average salary of all nurses in United States, there's no way you can go to all the houses and knock on the door, find the average salary of all the nurses. You will not be able to do that. So, but what you can do is go to maybe five states. Go to South Carolina, sample some states, get maybe 20 nurses from South Carolina, go to North Carolina, get a sample of 20 nurses, I go to Georgia, and so on. Maybe after you get 20 each from 10 states, 10 times 20 is 200. So you have a sample size of 200. And remember that the population of America is about 300 something million. Okay, as at 2 years ago when we looked it up. All right, so now you can now use your sample of 200 to find the characteristics. In other words, find the sample mean of that 200 and then use the sample mean to estimate the average salary of all nurses in the United States. Okay? And so when you finish that, you generalize into the whole population of America. So that's what we are actually, in a nutshell, that's actually what we are doing. We shall be using the sample statistic. Okay? If I'm doing it in percentage, then it means I'm looking for the proportion of nurses in the United States, in the 10 states. When I get the proportion, then I will generalize into the proportion of all nurses in the whole United States. So we say we are doing inference. We do this, we are doing inference. All right. Okay, so that's what we call confidence interval. But before we do that, there are conditions we need to talk about. What are the conditions for converting from binomial to normal? There are conditions for converting. We met binomial in Unit 3. So there are conditions for converting from binomial to normal. One of them, condition number 1, converting from binomial to normal, is that n sample size multiplied by success multiplied by failure must be greater than or equal to 10. And what does this mean? This is the variance. The variance. So the variance of that data must be greater than or equal to 10. Okay? That is condition number 1. Condition number 2, the sample size must be less than 5% of the population. All right, so the sample size, the estimated sample size is 200. And I already know that 200 is less than 5% of 360 million Americans. So I know that, so let's say we have 202 sample size of 200. And we found the average salary. But anyway, the proportion, let's just take the proportion because we're talking about p hat. We have a p hat of 0.7. Let's say 0.7. And then if I know the p hat, I already know q hat. Remember that in binomial distribution, we have two outcomes, success and failure. So p hat plus q hat is equal to 1 because it has to be, that is the rule. Success plus failure must be equal to 1. Remember, area under the normal curve is 1 because it's probability. Success plus failure must be equal to 1. So since success is 0.7, failure must be 0.3, 0.3. 0.3 plus 0.7 is 1. Okay. And then I can check and see, does it satisfy the first condition? If it satisfies the first condition, we can continue. So what does it mean? Does 200 multiplied by 0.7 multiplied by 0.3, is this greater than or equal to 10? Is the variance greater than or equal to 10? So what I'm going to do is get my calculator and multiply that. So pull up my calculator. It is right here. I don't know if I shared my calculator. I better share it. Did I even share this calculator? Fully I did. Anyway, multiply that 200 multiplied by 0.7 multiplied by 0.3. And when I get this answer, I'm going to do that again. Okay, 200 multiplied by 0.7 multiplied by 0.3. What am I trying to do? I'm checking the condition number 1. I want to see if this the question passes the test. Does it pass the test to convert from binomial to normal? So if I hit enter, I have 0.42. Actually, I have 42. In other words, this passes the test. Why? Because 42 is greater than 10. Therefore, the variance is 42. The variance of this sample is 42 and it is greater than 10, so we can proceed. Sample size, which is 200, is less than 5% of population, so that is good. And sample must be from a normal distribution. Yeah, we know that it's a simple random sample. It is a simple random sample to collect data from 10 states. And then, so the condition is satisfied. So we can now do a confidence interval. After this, we shall go to, after this, I made up this question. And after this question, we can go to practice test. So we can do an example. Before ever you want to answer a question on confidence interval or hypothesis testing in this unit, you must check the condition, especially if you are told to find the confidence interval for proportion. So this question is proportion. You must first of all test the condition. Is the variance greater than 10? You must know that. In other words, you have to use the information given to you to check it. So the variance is greater than 10 because 42 is greater than 10. 200 is sample size. Surely 200 is less than 5% of 360 million, which is the population of America. So we can do this test. We can do this confidence interval. All right. So what in the world is confidence interval, by the way? So suppose I'm told to do 95% confidence interval. What does it mean? What does it really mean? I'm going to draw a picture, even though we already know from the not central limit theorem, from empirical rule, we already know what 95% means. Whenever I'm told to do 95% confidence interval, I'm told to find the central 95% of the data. You want to check and see if they are within plus or minus 2 standard deviations. So the central 95% has to be within plus or minus 2 standard deviations. Okay, so now I am going to continue. This is the first example. So I'm making it up, and that's all it takes, though. It's not even difficult. So people think it's difficult, but I can tell you it's not difficult. So what are we going to do now? Assuming that everything is in order, and I'm told to do 95% confidence interval. So everybody look, I am going to draw a picture for normal distribution. I am checking if I'm doing 95% confidence interval. I'm doing the central 95% here. So what does it mean 0.95 or 95%? So remember that the area under the normal curve is 1. So 1 minus 0.95 is equal to 0.05. So the area on the tails are 0.05, 0.05, but both of them are 0.05. So I really want to find the area on one tail. So what is the area on this tail? So I'm going to divide by 2. If I divide by 2, I have 0.025. So the area on this tail is 0.025, and this is 0.025. Remember from empirical rule that I already know that this is approximately 2. Just know this is approximately -2, and this is approximately 2. Because empirical rule told me that plus or minus 2 standard deviations of the data lie within 95%. But I'm actually purposely using 95%, just so you know. So so everything we learned, even from unit 1, we're applying it in unit 4. Don't you see? We know empirical rule from unit 1, we're talking about it in unit 4. Okay, that is what is called an inverse norm. We already talked about it in unit 3. I want to find the area to the left, even though I already know this. Oh, I need to draw that again. I already know that. I want to confirm that the area to the left 0.025 gives me -2. Okay. And so I'll get my calculator. The reason why I want to calculate that is so you know, because very soon you will be told to find the critical value. So you will not be asking, what is critical value? So I'm about to calculate the critical value from my calculator. Even though I already know that the critical value is -2. I didn't know that from unit 1. So it's not a big deal. We did not call it critical value, though, in unit 1, but right now we are calling it critical value. The value of z that corresponds to the area on the tail is the critical value to the left. The value of z corresponding to the shaded area to the right is called critical value on the right. Okay? And this number, 0.025, will also be called alpha over 2. So alpha over 2 is 0.025. Remember, all these are new names now. We're having new names. Actually, it's only new names because we already know this. We already know all this stuff from unit 1, but now we're calling them new names. Alpha over 2, all right? 95% is now going to be confidence interval. But remember, empirical rule told us 68, 95, 99.7. We never called it confidence interval. Right now, we're calling it confidence interval. So we already know a whole lot of what we're starting to do today. But there are some names, new names. So the alpha over 2 is equal to 0.025. I'm about to use my calculator to find the critical value corresponding to 0.025. So that's critical value. So let me get my calculator and calculate the critical value. So get my calculator, calculate the critical value. Whenever I'm told to calculate the critical value, I'm doing inverse norm. Why am I doing inverse norm? Even though inverse norm is for normal distribution. But what? But I'm doing proportion. I'm doing confidence interval proportion. So why am I using inverse norm? Because this proportion question has passed the test for converting from binomial to normal. The test for converting from binomial to normal is passed already. In other words, the variance is greater or equal to the 10. It's greater than or equal to 10. The sample size is less than the population. The sample size is less than 5% of the population. The data is from a normal, simple random sample. It's a normal distribution. Okay, so I can now calculate that. So I'm telling you the reason why I'm doing inverse norm. Okay, so I'm going to call it inverse norm because it passed the test to convert from binomial to normal. In other words, convert from proportion to z. Okay, so where is this inverse norm? Again, I'm going to do second distribution. We already know where it is. The inverse norm is number 3 here. I'll select number 3. And it's asking me, what is area to the left? See why I divided the area by 2? Because it's asking me, what is area to the left? This area means area to the left, percentile. I talked about it last unit. So area to the left is always called percentile. And that is 0.025, 0.025. And the mean, this is a standard normal, mean is 0, standard deviation is 1. So I'm going to calculate the inverse norm. Because you know when I calculate it, it's going to be approximately 2. Approximately 2. See, negative 1.96. So approximately 2. So the critical value is negative 1.96. So this is negative 1.96. You can actually read the chart. When you read the chart, it's going to give you the same thing. And by the way, because normal curve is symmetrical, Normal curve is symmetrical, and area to the right is equal to area to the left. So this is negative 1.96. This is 1.96. You see, my calculator is more accurate. So negative 1.96 and 1.96. If I round them up, it's 2. According to empirical rule, the area 95% in the center is about plus or minus 2 standard deviations. According to my calculator, it's plus or minus 1.96. In this unit, excuse me, in this unit, you must use negative plus or minus 1.96. Plus or minus 1.96. So in this question, I will say that the critical value, and this is Z alpha over 2, Z alpha over 2 is equal to plus or minus 1.96. I will not write 2. I will not write 2. I will say plus or minus 1.96. Why? Because this is two-tailed. Every confidence interval is two-tailed. Every confidence interval is two-tailed. So you must use plus or minus 1.96. That is also a formula. I'm going to show you the formula and also show you how to calculate it with calculator. Okay, so I'm going to show you the formula. So I will clean. So I will clean. So I'm going to clean now. Perfect. Now I will write the estimate of the population proportion is equal to the point estimate P hat plus or minus the critical value alpha over 2 multiplied by standard error. The standard error for proportion is P hat Q hat, that times Q hat, a sample size. Okay, this is a square root P hat times Q hat over sample size. So this is actually the formula. If I'm told to calculate it with formula, then I must plug in everything I know here. So now P, the estimate of the population proportion is equal to sample proportion, which is P hat, which I already know is 0.7, that question, plus or minus, the critical value is 1.96, because I already found it, multiplied by standard error for proportion, and P hat is 0.7 multiplied by 0.3, and the sample size is 200. If you solve this problem, you get an answer. If you solve this problem, you get an answer. Let me tell you, this is the problem you will solve, and you get the correct answer, and your answer will be in percent. Remember, this is probability, so your answer must be in decimal or percent or fraction. So you cannot have more than 1. If you have more than 1, then you fail the rule of probability. Proportion is probability, whether you're doing population proportion or sample proportion. So your answer must be in percent or decimal. Okay. By the way, suppose I decide to do this with calculator. After this, we're going to go and do one from the practice test. So you know, this is not even difficult. So I'm going to pull my calculator up and do the same thing using my calculator. So how would I calculate this using my calculator? I will just clear. Whenever I'm told to do confidence interval, P confidence interval with my calculator. So I'll go to start, S-T-A-T. This is the first time we're doing this. I want to note this. P confidence interval, go to start, arrow to test, And this is confidence interval. So arrow to P confidence interval. I'm going to arrow down and 1 proportion Z interval is what I'm looking for. Why am I looking for 1 proportion Z interval? That is it here. 1 proportion Z interval. Why? Because I already said that before, that it passed the test to convert from binomial to normal. That's why we're combining proportion and Z. Normal is Z. And I select enter, select A. And then asking me, what is the sample size? I mean, what is the sample size of the out of? So I have to calculate that though. So let me calculate that. What is that sample size? So you got to watch me calculate that now before I continue. So let's calculate the sample size because it's not given to us, but we can calculate that. So, what is the sample size? All right. I mean, what is the number over the sample? So, p hat is equal to x over n. That is the formula. P hat is a percentage. For example, if I said that, of course, let's just put this number. So P hat is 0.7, 70%. And I don't know X, but sample size is 200. So can I calculate X? Sure. Cross multiply. So if I cross multiply, I have 140. Yeah, let's calculate that. Let's calculate what is 0.7 multiplied by 100. We'll come back to this later. So 0.7 multiplied by 200. 0.7 multiplied by 200. If I hit enter, I have 140. All right. Therefore, since my calculator is asking me for X, that's why I solved. What is 70%? Asking me, what is 70% of 200? Another way of asking me, what is 70% of 200? That's just what I found. And that is 140. So X is equal to 140. X equal to 140. Then I'll go back and feed that into my calculator. So go back. So I'm going back now and answer that question because I needed to feed it to my calculator. So now I will go back to start, arrow to test, 1 prob Z interval, which is A, 1 prob Z interval. All right, so I found A there, took it down. Now I know that X, 70% of 200 is 140, and sample size is 200. And the confidence level is 95%. So I'm going to calculate now. What am I calculating? The confidence interval. I'm calculating the confidence interval. So I calculate the confidence interval. And the confidence interval is, I'm going to write it down, is from point, if I write it in percent, I have from 64.65 to 75.35%. So this is what I'm going to do. Calculate the 0.64 or 0.6365. 6365. So I'm going to clean here on 6365. So let me clean this part. So I'm about to write the confidence interval. So you see, we use the point estimate to calculate the estimate of the proportion, population proportion. So the estimate of the population proportion is from 0.634 to, let me bring that calculator again so I can get the actual 0.6365 to, then I will also get right-hand side, 0.7635. 0.7635. What does this mean? 7635. This means that the estimate of the population proportion lies between 0.6365 to 7635. In other words, I don't know exactly what the population proportion is, but what I do know is from my data given to me, the estimate lies from 0.6365 to 0.7635. Well, this is how I answer the question. You really have to state your answer. You have to state your answer in a confidence interval. So I will say, therefore, I am 95% confident. So I will say, therefore, I am 95% confident. Why? Why 95? Because that's what I'm given. You cannot be more confident than what the confidence interval given to you. You must just be confident to the confidence level given to you. I'm 95% confident that the population proportion, that P, not P hat, P, population proportion lies between 0.63, I can just say 632.76. I can just put that. Or 63% too. If I draw a number line, the right-hand side is 0.76. The left-hand side is 0.63. The left-hand side is called the lower bound of the confidence interval. The right-hand side is called the upper bound of the confidence interval. Remember, the point estimate is 0.7. This is 0.7. We already know that. You might be told to find the distance from here to here. Okay? And that distance is called margin of error. Margin of error. So I'm going to find that distance. 0.76 minus 0.7 is 0.06. And margin of error to the left and to the right are equal. This better be equal. So here it should be approximately 0.06 if I round up here. So it should be approximately the same. They must be the same. By the way, the p hat is, because if I round this up, it's going to be 6.4. By the way, p hat is the midpoint of the line. Therefore, if it is the midpoint, the upper half and the lower half must be equal. And therefore, I can be told to find the margin of error. So I can say, let me rewrite the confidence level. Remember, you have to state your answer. Therefore, I am 95% confident that P lies, the population proportion, which I don't know, lies between the lower bound, as I saw in my calculator, and the upper bound. If I'm told to find the margin of error, I'll find the distance between the lower bound and upper bound and divide it by 2. Okay, and that margin of error, you can actually use it to, so let me restate. I can actually restate restate my answer. So I am 95% that the population proportion lies between, let me start from here to clean, lies between point estimate, so lies between the point estimate given to me, p hat plus or minus. So the population proportion is equal to point estimate plus or minus margin of error. So margin of error. If I add margin of error to P, then it's going to be upper bound. If I subtract margin of error from P, it will be the lower bound. Okay, so if it looks difficult today, it's really not difficult. So today is the first day, so we are actually saying what we're going to be doing for the rest of the semester. The rest of the semester is until almost 3 weeks from now, because our unit 4 test is around the corner in 3 weeks. And therefore, you have to start now to study. Unit 4 is open, so you can start now to study. I'll make sure that all the things you need to study Unit 4 will be in Blackboard today. Everything you need to study, actually not today, not upload PowerPoint and the notes. This is a note. So the note. Then I'll upload some videos by end of this week or next week. And so if you start now to study, you will not have any problem. If you start now to study, you don't even have any. If you start now to study, you will not have any as you. Okay. Let me see. I don't really think we have enough time to do an example. I don't think we have another. Well, we still have time. On Thursday, we do. So today we started with confidence interval for proportion. So we shall continue to do confidence interval for proportion, calculation of sample size for proportion. Do that Thursday again, because we didn't start on time today. And after we do that today, we will also, let me make this smaller. Next week, we start confidence interval and calculation of sample size for the mean of a population, mu. So today is for P. This week is for P hat and Q hat and the conditions. So we talked about the conditions. So next time we shall do the mean, which is mu. We shall be looking for the mu because you are not expected to. I already said that. I'll keep saying it. You're not expected to know the mean of the population. So you are going to be using the point estimate. The point estimate for population mean, mu is X bar. That is the point estimate. X bar is the point estimate for population mean. P hat is the point estimate for population proportion. We're not doing standard deviation, though. We are not. But standard sample standard deviation is the point estimate for population standard deviation. So you get that. You actually get that. But we're not doing this. This is not in our syllabus, so you're not going to see it in our class. We're only going to do mean and proportion. Mean and proportion. So we started proportion today. And we're going to do proportion again next class. So there will be no need for me to rush another example. I did an example today. It may not be clear, but this is a good start. You really know that the proportion we're talking about, it's the same as the same proportion we see in binomial distribution. Proportion is going to be probability. So proportion obeys the rule for probability because it's still binomial, and there are conditions. There are three conditions that must be obeyed before you do inference for proportion. That's why we have to do another example. I'm just going to say it again. I said it today. I want to say it again next class. Whenever you see p hat, you see it's a sample proportion, sample characteristic. When you see p, it is population proportion. Okay. P hat, sample proportion, p, population proportion. When we start doing mean of a population, you see that the point estimate will be x bar. X bar is the sample mean, and then mu will be population mean, and we're not supposed to know the parameters. So we shall be estimating the parameters. We're not expected to know them. If you know the parameters, what are you actually doing? Because the essence of doing this is to use the sample to estimate the population parameter. Really, we need to stop here, but just making sure that this is an introduction of Unit 4. Again, congratulations, you come to the end of this class. So very soon you'll be finishing. At the end of this month, we take Unit 4 tests, and then maybe, I think if there is no change in exam day, then we use what is in Blackboard. So I wanted to check Blackboard and find the dates. The dates are there. For those of you who miss tests and tell me they don't know that we have a test, you don't even telling me the truth, because the dates for all these tests and exams has been on Blackboard from the first day you registered for this class. So check the calendar, check the announcement. Check the announcement all the time if you think you're missing something. Don't give flimsy excuses for missing a test or missing an exam. Because if you miss an exam, it's not going to be easy. Some of you already missed 2 tests. I don't know what you want to do. And you did not drop. But one thing that I do know is that final exam will replace 1 test, 1 test, 1 missed test, or 1 low test grade. The other one is going to be 0. We said that the first day of class, right? It's in the syllabus. You cannot miss a test, but some of you already missed 2 of them. Anyway, all right, so you have a great week. We will do this again. This is the first day. So in this introduction, I want to repeat what I said today. I want to do another example of population, calculating the population proportion, using the formula, using the calculator, finding the critical value, checking the conditions for converting from binomial to normal, and all the rest of them. So you need to know how to do all these steps. You need to know how to do all these steps by final exam. It will be in Unit 4. It will be in final exam. So it can't run away from you. If you don't know it, then you fail Unit 4. Okay, so you want to know what I'm talking about. So you will pass Unit 4 and pass final exam very well. So you continue to do well. All right, you have a great day. Stop so far. Stop sharing. get out of this window. Yes, I'm going to leave this one also.